All right, welcome back, physical science students. So the first section that we're going to work on, we're going to break these apart, is potential energy and kinetic energy. So potential energy is all about position, mass, and height. And our answer gets derived into a unit of energy called joules. So in this formula, which is posted on the board, potential energy is equal to mass times gravity times height. And we answer it with a big J for joules in regards to James Joules, who is credited for this. When we work with this, mass is always in kilograms, so kg. Gravity, in this situation, since we're going to be working with Earth, is going to be 9.8 meters per second, and height will always be in meters. So instead of feet or inches or kilometers, we're going to go meters, and our answer is going to be in J. So I'm going to put up some practice problems. These ones are already emailed to you or are in your Google Classrooms. It says potential and kinetic energy worksheet. I just took a worksheet of mine, solved the problems, and then uploaded it for you guys. So that way you guys can use this as practice problems, and guided practice problems. So let me erase the board really quick. And I'm going to do these for you guys just so you can see the steps involved. And then from there, you guys can run with it yourselves. So number one, my mass of an object is 75 kilograms. It says my height is equal to 300 meters. Gravity is going to be 9.8. But we don't know joules. So in this problem, we're just solving directly for joules. So mass times gravity times height. So I'm going to have 75 times 300 times 9.8. And my answer on this one will come out to 220,500 joules, just like that. Okay. So let's do number two really quick. And I'm not trying to push these along quickly. I'm just using my iPhone on a very weird situation with a brick, a stand, a whole bunch of chemistry equipment to hold everything up. So hopefully it doesn't come crashing down on us. All right, so next one, similar to the first, mass is equal to 10 kilograms. Height is equal to 2 meters. G is equal to 9.8. And joules, I don't know. So I don't know my potential energy. So, like before, and you guys can put this in parentheses too in your calculator if you like. It makes things easier. So you can do 10 times 2 times 9.8. And that will give you 196 joules. Okay. Now I'm going to leave that one up there, and I'm going to move to one which we have to solve for an unknown. So in this one, I'm given the mass. It's 50 kilograms. My potential energy is equal to 9,800 joules. I know G is still 9.8, but my missing thing here is height. So that's my question mark. So this is going to be set up like an algebraic equation. So we're going to isolate our 9,800 joules on one side of the problem. So I got 9,800 joules. It's going to be equal to what we know. So I've got 50 times 9.8 times x. Okay? So I'm going to multiply 50 times 9.8. And if I do that, I'm going to look at my formula here. I'll have 490 times x. And we're still equal to 9,800 joules. Okay, to solve for x, I'm going to divide by 490. I'm going to divide by 490. Okay, so I'm going to get rid of this. What I end up with in the end is x is going to be equal to 20. But again, what am I solving for? I'm solving for height, so I need to put that as in meters. So that would be my final answer. All right. So next, we're going to work on some kinetic energy, which is all about speed. So it takes into consideration velocity and mass. And it has a little bit more of some ups and downs with some of the solving, since we have to use square root, but it's nothing too crazy. So please refer to this video, and if you have any questions, please reach out for help as we work through some of these practice problems. You guys will see an assignment in your classroom, Google Classroom platform soon. They'll be associated with potential energy. All right, hope you guys are all doing well, and I'll talk to you soon. Thanks, Mr. Chair.